Good morning, Dr. Ashish. Dr. Ashish, good morning. Dr. Ashish. Good morning, Doctor. Doctor, your voice is not. Good morning, students. We are entering the fourth day of the BIIS-11 workshop. Today, the first session, we have Dr. Ashish Patel with us. He is working as an assistant professor and specializing animal genetics and breeding in the College of Veterinary Science and Animal Husbandry, Kamadhenu University, Anand Campus, Gujarat. Dr. Ashish Patel has graduated in the year 2006 from Veterinary College, SDAU, and he did his master's in 2008 and PhD in 2019 in the subject of animal genetics and breeding from AAU, Anand Agriculture University, Anand, Gujarat. Dr. Ashish Patel is currently working as assistant professor in the of animal genetics and plant breeding at the Veterinary College since March 2012. Dr. Ashish is actively involved in undergraduate and postgraduate teachings. He is also involved in several department research projects on breed characterization using microsatellite markers, A1, A2 genotyping in cattle and buffalo, genetic disease testing in cattle and buffalo. He is also involved in postgraduate students' research data analysis and bioinformatics analysis. He was involved in characterization and registration of five new livestock breeds via Duma sheep, Kami goat, Kalari donkey, Kachi donkey, and Dagri cattle. For characterization and registration of new livestock breeds, he was awarded for the Kamadhenu University Award in 2020. Dr. Ashish Patel has published more than 10 research papers in international journals, 25 in national journals, 50 research abstracts in seminars and symposiums, 20 popular articles, and 2 book chapters in vernacular language. With this short introduction, I invite Dr. Ashish to deliver his lecture. The floor is yours, sir. Doctor, are you able to hear me? My voice is. Here we have no problem with our voice. My voice is. Yours only yours, I think. Can you check and just join back? You can join back. He left and he will join again. Doctor, can you hear me?
Yeah, okay. Hello, am I audible?
Yes, doctor.
Okay, thank you, sir. So I can share my PPT. So can you able to see the PPT?
Yes, doctor.
Sir, why it is echo sound?
Echo is coming.
Hello.
Hello, doctor. Can start.
My voice is clear,
Yes, doctor.
or is there any echo?
It is clear, doctor. You can start.
Okay. Thank you, sir. And good morning, everyone. Today I will conduct this session on descriptive statistics. So name itself indicates descriptive that describes something about the data. Sir, I think mute yourself. मुझे इको आ रहा है सर, इको साउंड.
Echo is coming from your voice.
From my side.
Yes, doctor.
Hello.
Hello. Yeah, now better.
Still I am problem. Hello.
Now, doctor.
Hello.
Now better, doctor. Clear.
Okay. So today we will see the descriptive statistics. So descriptive statistic name itself indicate that it describes something about data. So before going to start this descriptive statistic, let us understand what is the statistic actually. So statistic, that is the, we can say it is the study of simply collection, compilation, classification, analysis and interpretation of numerical data. So it is simple, we can say statistic in which we have to collect the data, we have to compile, we have to organize or classify, analyze, and finally interpretation of that numerical data. So biostatistic, that means when we apply this statistic to the biological science, it will called as a biostatistics. So before going to start descriptive statistic, you have to understand certain terminology. Okay, so that include the data. So what is data? So data, that is the, we can say it is a numerical information. Numerical information that we can collect either by the process of counting or we can say measurement or like that. So data may be of two types, quantitative data and qualitative data. So qualitative, that describe the we can say something quality. Okay, so am I audible clearly? Hello.
Yes, doctor.
Hello.
Yes.
Sir, आवाज आ रही है ठीक से?
Yes, sir. It is clear. You can continue.
Hello. Hello.
Hello.
Voice is clear?
Yes, doctor. It is clear. You can continue.
Okay. So qualitative data that describes something about quality. So that include the body, color, then type of hair, color, etc. And quantitative, that indicate some numerical information. So this quantitative data that are also again classified into the various categories, that is discrete data, when the whole number discrete data, that means it isn't in the class, number of animals on the farm, then we can say number of accident on the road. Okay, so it will take whole number only. Second, it is a continuous data. So when we take when we can say any variable, it can take any numerical information or numerical range. Okay, value. So that is example, height of the student, then body weight, then mark obtained in the examination. That are the continuous data. Then another, that is the univariate data. So data of only one variable. So univariate, that means when we talk about the only single variable at a time, so we can say it is a univariate. And when we working with the more than one variable, so it is, we can say, multivariate data. Okay, so bivariate, that means we are working with the two variable, for example height and weight. Okay, so sir, my slide is moving or not?
Yes, sir. Moving.
Hello.
Yes, doctor. It is moving.
Hello.
Hello.
My slide is moving.
Yes, doctor.
Population. So what is population? So we can say population is a group of individual. Okay, so some people on any time we heard about the population, so first thing come into the mind, that is the population, that is the group of individuals. So we can say it is not only the group of the individual or human being, it is a group of animal or business or building, whether it is living thing or non-living thing, that is also considered as a population. Then sample, it is a subset of population that represent the whole population. Then parameter, so it is a, we can say, numerical quantity that include the mean, median, mode, like that. Variable, so we can say any character which is under study, and it also vary from individual to individual and also vary from time to time. मतलब जो ऐसा character जो time to time change होता है, individual to individual change होता है, so we can say it as variable. For example, number of legs in the animal. Okay, so can we consider that it as a variable? So no. Why? Because it is not vary from individual to individual. Also, it is not vary from time to time, because it is an animal, particularly cow, having four legs. Okay, so all cows that having a four legs. Okay, so we can say that it is not vary. It is fixed. Okay, exceptional cases is there, but generally we can say majority of the population, cattle population, they are having four legs. So this number of legs in the cow, it is not considered as a variable. Okay, so variable that must be vary from individual to individual and also vary from time to time. Then variate, that means when the variable take any value. For example, this body weight. So body weight, that is our variable. But if we measure this body weight in particular, suppose it is 50 kg. So this 50 value, that is, we can say it is a variable. So this again, this quantitative variable categorized into the when in the form of category, then it is categorical variable. Then as I explained earlier, that is the discrete variable and continuous variable. Then collection of the data. So it is a simply we can say information collection. Okay, so process of counting or measurement or listing together the system of recording, that is called as a collection of data. So before going to the analysis, we have to collect the data. Okay, so the data are two type data based on the class collection of the data. So first is the primary data. So the data which is originally collected by the investigator himself or herself first time. जब भी आप first time आप data collect करते हैं, so it will become a primary data, okay, for you. But if that data, if I use, then it will become a secondary data for me. That is that data will remain for that data will remain primary data for you, but it is secondary data for me. Okay, so secondary data, that means the data which have already collected by the some agency, some NGO or some any government institute or whatever, and it is used by the person. Suppose government ने सर्वे किया, ओके, लाइव स्टॉक सेंसस किया, ह्यूमन सेंसस किया, तो मैं तो ह्यूमन सेंसस नहीं कर सकता. ओके, सो गवर्नमेंट ने किया, सो गवर्नमेंट के पास जो डेटा है, तो दैट इट इज कॉल्ड एज अ प्राइमरी डेटा फॉर गवर्नमेंट. अगर मैं गवर्नमेंट की साइड से मैं डेटा एक्सेस करता हूँ, सो दैट विल बिकम अ सेकेंडरी डेटा फॉर मी. ओके, so whatever the data we are finding in the newspaper, periodical, magazine, scientific journal, book, all are, we can say it is a secondary data. Now let us come into the specific topic, that is the descriptive statistics. So name itself indicated describes something about the data, about the numerical information. So descriptive statistic, that is used to describe the basic feature. Okay, this is the preliminary features of the statistic. Okay, आपको descriptive statistic तो मालूम होना ही चाहिए. मतलब कुछ भी डेटा हो तो हम पहले क्या करते हैं, उसका descriptive statistic we are doing. Okay, so they provide the simple summaries about the sample and measure. So whatever the data we have collected, from that we can find something simply summary form information. So with the descriptive statistic, we can simply understand or describe what is and what the data show. Okay, agar data simply statistic or descriptive statistic, it will give the idea about the what is the data actually. Okay, हमारे data में क्या है. Okay, so we use the descriptive statistics simply to describe the what's going on our data. Okay, if is there any outlier, is there outlier, that means other than the normal observation. मान लो कि आप डेटा कलेक्शन कर रहे हैं, सपोज यू आर कलेक्टिंग योर डेटा regarding to the body weight of the human being. Okay, so data definitely it will come within a range of 30 kg, or if you are talking about the adult, so it will come ranges from 40 kg to 80 kg, 90 kg, exceptional cases 110 kg. Okay, but if suppose if you have any typing mistake and instead of 50, if you write the 500, so definitely this 500, that is called as outlier. Okay, so it will affect your data. So from this descriptive statistic, we can identify is there any outlier is there or not. So descriptive statistic can be used to present the quantitative description in manageable form. So if we have 1,000 of the data, if you do this simplest descriptive statistic, it will be concise in the form of 5 or 6 values. Okay, so definitely it we can say describe whole data into the manageable form. Then each descriptive statistic reduce the lots of data into the summary, simple summary. As I told, if you having a lakh of the data or million of the data, then if you do this simply this descriptive statistic, it will give the summary of all the data. For example, suppose the simple number of some this descriptive statistic or summarize how well a batsman is performing in the cricket. तो हम क्या करते हैं उसका एवरेज देखते हैं. We are watching about the average of the each batsman. On the basis of average, we can say yes, Virat Kohli is a good batsman. Okay, so grade point, it is a single number. So on the basis of grade point, we can say yes, this the person is topper in the class, or person having the average in the class, or like that. Okay, so that is, we can say it is simply average. But on the basis of this average value, we cannot tell whether the student having any difficulty in particular subject or not. Okay, suppose you have a 5 different subjects, and if your overall grade point it is a 9. Okay, so definitely you are considered as a brilliant student. Okay, so on the basis of 9 grade point, definitely it is considered that you are brilliant student. But if you see that individual performance of the subject, so suppose physics is there. Okay, so in physics there is a grade point, it is a, we can say it is a 7. Okay, so this average value that cannot describe whether this student is having some difficulty in particular course or not. Okay, so that is the limitation of this average value, or we can say descriptive value. So with this limitation, descriptive statistic provide the powerful summary that enable the comparison across the people or other units. So on the basis of this simply simple summary or descriptive statistic, we can compare the different population. So let us see for the univariate analysis, descriptive statistic for univariate. Okay, so univariate name itself indicates the uni, that means only one, variate, that means only one. So when we consider only the one variable at a time, so it is a univariate. Okay, so I am taking the only one variable at a time. Suppose I am taking the body weight or height at a time, only one variable. So it is a univariate analysis. If it is multivariate analysis, that means suppose I am talking about this height, body weight, then all other characters, number of marks, number of we can say bike, whatever it may be. So we can say it is a multivariate analysis. Okay. So in descriptive statistic, it is divided into the mainly 3 categories, that is the distribution, central tendency, and dispersion. Okay, distribution, that means what is the actual data is there, what is the, how this data are distributed over the we can say variable. Then central tendency, that means it will give idea about the central value, and dispersion, that will give idea about the scatteredness. So let us see the what is distribution. So distribution, that means it is a summary of the frequency. Okay, simply we can say it is a summary of the frequency of the individual value or range of the value of the variable. Suppose here if you want to do the survey, then if you do that, how many student, how many person in the particular city, they are having a, what we can say, having a different specific age range. Okay, suppose here if you do this survey, then you will find that under the 35 year of the age, so 9% population, 36 to 45, 25 or 21%, 45%. So this is what we can say distribution of the data over the particular categories. Okay, so that is, we can say, frequency distribution. So this frequency distribution that can help about the we can say what is the majority of the population, or we can say majority of the category. Second, that is the central tendencies. So descriptive statistics that include the first, that is the distribution. Okay. Second is the central tendency. Name itself indicates central tendency. That means tendency to remain at the central position. So the tendency of the variate value or a variable or value in a series to get the cluster around the certain representative value, that is known as the central tendency. Or we can say the value of the variate which thoroughly representative of the series as refer as a central tendency. So in simple language we can say central, that means the central tendency, that means tendency of the data tendency. So various measures that describe the central value that include the arithmetic mean है, weighted mean है, then geometric mean है, harmonic mean है, median है, mode है. So out of this, all the measures of the central tendency or central value, the most commonly used measures, that is the arithmetic mean. Okay. Then median and mode. This weighted mean, geometric mean, and harmonic mean, they are rarely used. Okay, so this central descriptive statistic that describe only the arithmetic mean, median, and mode. So it does not include this part, weighted mean, geometric mean, and harmonic mean, because it is not much important. So let us see first, that is the arithmetic mean. So simply we can say it is the average. Okay, we are routinely use this arithmetic mean. Okay, every day. If you want to do the average value, okay, मुझे देखना है कि भाई आज मैंने मेरा monthly average expenditure कितना है. So average, that means what? So it is a simply sum of all individual observation divided by number of items. So आप पूरा हर रोज का जो एक्सपेंडिचर है उसका टोटल करोगे डिवाइडेड बाय 30 और 31. Okay, so you will get the average expenditure of the month. So this arithmetic mean, it is most commonly used this central value. Then this median it is also central value. Okay, so median, that is, we can say the variable which divide the data series into the two equal parts. Okay, so what it is doing, so it divide the data into the two equal part. So आपके पास data है, so it will divide the data into the two equal part. So sorry. So this is your data. Okay, so this median, it divide the data into the two equal part. Okay, so that is called as a median. So it describes the value which are the greater than median. So these are the data. So these are the less than median. These are the greater than median. So median, that means you have to we can say it is also positional average. So it is a positional average. So it depends on the on which position it occupy the on the data series. So this median, we can say how to calculate this median. So median, that means it is a middlemost value after the arranging the data either into the ascending or descending order. मान लो कि आपके पास 1, 5, 3, 2 ऐसे वैल्यू है. So first you have to arrange your data into the either ascending order or descending order. So once you arrange your data into the ascending or descending order, whatever the middlemost value, that is called as a median. So first arrangement of the data in the ascending or descending order, and if the number of observation are odd in number, so we have to use this formula. If the number of observation are even in number, then we have to find out the this formula, average of this n by 2th observation and n by n plus 2 plus n plus 1. Here it is n plus 1. Sorry, it is n plus 2 divided by 2th value. So this is the example. So 5 observation are there: 35, 12, 40, 50, and 8. So first we have to arrange the data into the ascending order. So it is 8, 12, 35, 40, and 50. And here the number of observation are odd in number, so simply 5 plus 1 divided by 2, so it is the third observation. So third observation after the arranging the data, that is the 35. So 35 is the median. If it is the number of observation are even in number, so these are the even in number, 6 number of observations, 6 observation are there. So we can say first we have to arrange, and here we have to find out the arithmetic of 2 middle value. So यहाँ पे according to this formula n by 2, that means third observation and fourth observation का average निकालना है, so it is 37.5. So we can say median value it is a 37.5. Another measures of central value, that is the mode. So mode, that is the most frequently occurring the data in the entire set of the observation. So for example, these are the data 10, 27, 24, 12, 27, 27, 20, 18 and 15. So out in all of the observation, 27 it is occurrence maximum time, 3 times. So we can say this 27, that is our mode value. Okay, so arithmetic mean, definitely it is a single value. This median, it is also single value, but mode may be of more than one value. Okay, मान लो कि if it is suppose instead of here it is a 10, here it is also 10, and here also 10. So what will be the mode value? Mode value will be 10 and 27. Both are considered as a mode value. Okay, because the mode, that is simply we can say highest frequency observation. Okay, so यहाँ पे दो observation है, उसका maximum frequency है. So here two values which have a maximum frequency. So we can say it is a 2 mode value. Okay. So this mode value, it may be single, it may be 2, or we can say bimodal or 3 trimodal or like that. Okay. Now another third part of the descriptive statistic after this central tendency, that is the measure of dispersion. Okay. So dispersion, that it will give the idea about the scatteredness of the observation. Okay. So मान लो कि if you have a 3 different series, data series, here it is a 3, 3, 3, 3 observation. So what will be your average value? It is a 3. If it is second data series 2, 3, 6, 1, so average value it is again 3. Another data series 4, 3, 4, 1. So the mean value or average value it is again 3. So only the simple average value or central value cannot describe the variability present in the data. Okay, इससे mean value से हमें पता नहीं चलता कि what is the data range actually. Okay, we cannot come to know that what is the actual data there going on. Okay, so here we can say these are the 3 different three different data series are there. Okay, but the mean are same, but the data are the different. Okay, so on the basis of that, we cannot say what is the scatteredness of the data. So the central value, or we can say mean, arithmetic mean, it is always supported by the measures of dispersion. So degree to which the numerical data are spread about the average. Average के आसपास कितना data spread है, so that will give idea by the dispersion. So we can say dispersion, that is we can say spread of the observation in relation to the measures of central tendency, or we can say degree of scattering of the observation around their mean, that is called as a dispersion. So there are various dispersion. So particularly it classified into the mainly 2 categories. So absolute measures of dispersion, they are having a we can say a unit, specific unit. Okay, whatever the unit of the variable, that is we can say unit. So for example, range है, interquartile range है, quartile deviation है, absolute mean deviation, variance, standard deviation, standard error. So they are considered as a absolute measure. A relative measure of dispersion, that includes the coefficient of range, coefficient of mean deviation, coefficient of the variation. So all are relative measure of dispersion. So out of this absolute and relative measure of dispersion, this range, it is important, then variance, standard deviation, then standard error, coefficient of range, or we can say CV% coefficient of variation, they are commonly used. So first range, that is the it is everybody aware about the range. So it is the difference between the largest value and the smallest value. So the example is there. Okay, so range, that is the highest value 150 and lowest value, that is the 50. So it is 100. So we can say range, it is 100. And coefficient of range, that is the highest minus lowest value divided by highest plus lowest value. So it is, we can say it is 150 minus 50, 150 plus 50. So it is 1/2. So it is 0.5. So this is coefficient. So coefficient of range key, what will be the unit of coefficient of range? It is a unitless. Okay, इस पे यहाँ पे कोई यूनिट नहीं, लेकिन what is the range of this 100? Okay, मतलब what is the unit of this range? So unit क्या होगा? So whatever the wages, so that means it is a rupees. Okay, so range का यूनिट होगा, लेकिन coefficient of range का यूनिट नहीं होगा. Directly jump on the standard deviation, because other quartile and quartile deviation, they are not much important measure of dispersion. So standard deviation, so we can say it is a square root, root mean square deviation, or square root of variance. So it is a positive square root of the arithmetic mean of the square of deviation of individual observation from the arithmetic mean. If you read this simple definition, it will be always confusable, and it is very difficult to remember this definition. But if you see the formula, then it will be easy to remember this definition. So standard deviation, it is a square root of the variance. It is symbolized by the sigma, or we can say S. So here we can say this is the formula. So now you can understand the concept of this standard deviation. So it is the square root of average of square of deviation of single individual observation from their mean. Okay, so that is called as a standard deviation. Now you read, it is a positive square root of arithmetic mean of square root of deviation of individual observation from their mean, that is called as a standard deviation. So यहाँ पे population mean भी हो सकता है, यहाँ पे population mean भी हो सकता है, और we can say simply sample mean भी use कर सकते हैं. So these are the properties of this standard deviation. So standard deviation, it is not affected by the change of origin, but it is affected by change of scale. So it is not much important. Another measure of dispersion, that is the standard error. Okay, so standard deviation. So average, it is always supported by the standard error. Okay, so आपने कहीं पे भी देखा होगा कि यहाँ मीन वैल्यू लिखा होता है, उसके बाद में प्लस और माइनस करके इस तरह का होता है कि आपने यहाँ पे सपोज 2.5 प्लस और माइनस 0.25. So this 0.25, that is, we can say it may be standard deviation or it may be standard error. So standard error, that is the standard, it is the square root of variance divided by n, or you can say simply, better to remember this, standard deviation divided by square root of number of observation, that is called as a standard error. Then variance, it is a simply square of the standard deviation. Okay, so we can say यहाँ पे अगर square root हटा दो तो it will become a variance. If you put here square root, suppose if you put here square root, यहाँ पे suppose if you put here square root, then it will become a, we can say, standard deviation. Okay. And another and most important measures of this dispersion, that is the coefficient of variation. So coefficient of variation, so it is the relative measure of relative. Because why it is relative? Because it is in the form of numerator and denominator. So it is coefficient. So it is a ratio of, we can say, standard deviation to mean. So यहाँ पे this is the standard deviation divided by mean value. So that is when multiply with the 100. So it is called as a coefficient of variation. So it have a unit, that is percentage. So smaller the CV percentage, the greater is the consistency in the samples. मतलब आपके sample में मान लो कि data है 1 है 2 है 3 है 100 है. ओके, और दूसरा डेटा है 1 2 3 5, 10. So if you find out the CV% from both data, here the CV% will be less, okay? But here the CV% it is a high. Q high hai because the here observation it is 100, okay? And here there we can say less variation in the data, but here it is a high variation. So on the basis of we can say CV%, we can come to know what is the actually data range is there. So generally, this is the about the descriptive statistics. So descriptive statistic, it is including every program. You should use this simple statistical software because descriptive statistic के लिए आपको कुछ करना नहीं, मतलब कि आपको manually जो calculation करना नहीं है. You have to use these certain statistical packages, available packages, or you can use the Excel also. So these are the considered as a statistical. We can descriptive statistic, okay? So it will give the idea about the number of observation, mean value deta hai, it will give the median, mode, standard deviation, variance, and range, okay? So how to do this analysis in the Excel, okay? So I will show you how to do the analysis in the MS Excel. Hello, my screen is visible?
Yes, doctor.
Hello.
Yes, doctor, it is visible.
Hello, sir, my screen is visible?
Yes, doctor. Yes, doctor.
Hello. Hello.
Hello. Can you hear me, doctor?
Please reply me.
Yes, doctor. It is visible.
Okay. So here this is MS Excel. Okay. So here you have to install the data analysis option. So how to install the data analysis option in your Excel? So first go into the file menu. Okay. आपको file menu में जाना है और यहाँ पे Excel option है. Here it is option is there. So if you click option, then it will show this page. Okay. So यहाँ पे you have to go with the add-ins. कहाँ पे जाना है आपको? Add-ins. You have to go with the add-ins, and here it is analysis tool pack is there. So again I repeat, in the file menu, go option, add-ins, analysis tool pack, and here you have to go. So it will ask which one to you have to select. Okay, so you just click on the analysis tool pack, click OK. So it will take time, and automatically it will one option will come into the here. So here in the data, one option will be visible, data analysis. Okay, so if you do the data analysis, okay, suppose I am taking the, any random value. Suppose I want to find out the descriptive statistic for this value. Okay, so go into the data option. Here it is the descriptive statistic option is there. Click OK, and it will ask input data range. So you just click on this symbol here, and you select it. Again, click on that. Then your data it is column wise. So yes, my data is column wise. अगर आपने ऐसे लिखा है row wise तो आपको select row. But here my data is a column wise. So okay. Then label है. Suppose for example here it is I am again max is there. Okay. So again you can see here descriptive statistic. I am selecting the my data including the title. Okay, तो यहाँ पे लेबल मैंने क्लिक कर दिया कि मेरा फर्स्ट रो में लेबल है. Now here summary statistic. Okay, and click OK. So here it will give the descriptive statistic. Okay, so mean value, standard error, median, mode, standard deviation, variance, kurtosis, skewness, range, minimum, maximum, sum, count, everything. Okay, this is the one method to get the descriptive statistic. Another method, here also, simply if you click, it will be visible that here you can see the average, count, minimum, maximum, sum. Okay, so here also you will get the simple information. Okay, not, it will not give the idea about the standard deviation, variance, but it will give idea about the average, sum, count. Okay, so you can see here. Okay, another way to district that include this is one method. This screen is suppose here. Suppose you write here. Suppose you ICAR Goa VAS. ये आपको याद है गोवा VAS. Click on that. So here you can see. Welcome to web stat packages. Okay. You can see basic statistic, descriptive statistic. Okay, so here statistic पे आप click करोगे, so it is asking that here how many observations are there. Suppose I have a 10 observation, so click on this tab, so it will ask about the data. Okay, so suppose I am randomly giving the data. Click on OK. So here, if you do the click on view result, it will give the result. So here number of observation, maximum value, minimum value, range, total, average, standard deviation, variance, standard error, CV% coefficient of variance. So all data, all information you will get on the single click. Okay. So this is the way to calculate the descriptive statistic, and it is a preliminary. So everybody, those who are dealing with the we can say research or everything, whether they are doing the MSc or whatever. Okay, you must aware about the descriptive statistic and how to do the analysis in simple Excel, or you can say this VAS or anything. Okay, because it is very important. On the basis of this descriptive statistic, I can say that yes, minimum observation it is 10, maximum it is 24. So मेरे data है, I have data in the range of 14. And total average value, so we can say average marks, it is 16 marks out of whatever it may be. Then standard deviation, yes, it is a less variation. Variance, it is a 26. So we can say yes. Here it is average, it is 16, but the standard deviation and variance, it is too much high. So we can say there is too much variation in the data. Standard error hai, then CV%. So we can say CV%, it is also it is somewhat high. Okay, if the CV percentage it is less than 20, then we can say our data, they are consistent data. So here, suppose your data here, again same I repeat. Suppose I am taking 5 observation. 10, 11, 11, 10, 11. So here my data having no much variation. Now you can see the CV%. It is less CV%. So as the CV percentage it is a less, we can say data are more consistent. Okay. Suppose I am changing my data here. It is 18. here it is 20, here it is 22, and here it is 23. So now you can see the CV percentage, it is more than 20%. Okay, so we can say the CV percent as it is high, we can say the consistency in the data is not there. But if the CV percentage it is less, so consistency is there. Okay, so CV percent it is commonly used, we can say, descriptive statistic to see the what is actually in data. Okay, so this is about the descriptive statistic topic. Okay, so let's move on this PPT. So again, here you can see this is Excel, how in Excel how to do the analysis. Okay, then this VASP, okay, how to do the analysis, and this is the SPSS software. So but it is the licensed software, so in that also we can get the descriptive statistic. So this is how we can do the analysis in the SPSS software. So it will give the idea about the n, range, minimum, maximum, sum, mean value. Okay, so descriptive statistic it will give in this form, standard deviation, variance, like that. Okay, this is about the descriptive statistic. Now if you have any question, you can ask me.
Thank you, Dr. Ashish. The session is open for discussion. Students, if you have any
Sir,
questions, you
I am
can
not
ask.
audible. आपकी आवाज नहीं आ रही सर.
Now you are getting my voice. Doctor?
Hello.
Doctor, can you hear me?
Hello. Sir.
Hello.
Okay, if someone have doubt, they can we can say send message to me. Okay,
Message
to me. Okay, so
okay,
you can see this. This is my email ID. If you have any doubt, you can ask me on this number. Okay, this is my mobile number and this is my email ID. Okay, because what is interquartile range? Yes, quartile that means the data, or we can say it is a value which divide the data series into the four equal part. Okay, quartile that divide the data series into the four equal part. जैसे आपने देखा होगा कि 10th marksheet or 12th marksheet, it is percentile is there. Okay, so what is percentile? So entire the data it is divided into the 100 parts. Okay, so from minimum to from maximum, your data it is divided into the quartile. That means it divide into the four equal part. Yes, this is nay. This is another wrong. Okay, so this is my email ID: AASHVET@kamdenu.uni.edu.in. Ashish Vet. Okay, so this is my email ID. Okay, so you can, if you have any doubt, if you want to learn anything about the statistic, you can ask me. Okay, anytime you can call, you can send the message. Okay, so because of I am not getting the voice from sir, so I think I have to stop here because I have another lecture. Okay, so sir,
Thank you, Doctor.
I am leaving. Okay, please permit me through WhatsApp, through this chat, because I am not getting your voice. Okay, sir, I am leaving.
Okay, thank you so much, doctor.
Okay, sir, welcome, sir. Thank you very much.
Good morning, Dr. Shagin.
Good morning.
Students, we'll move on to the next session of the day. We have with us now Dr. Shagina Begum, Scientist E from Department of Biostatistics, National Institute for Research in Reproductive and Child Health, Mumbai. Dr. Shagina has a PhD from AIIMS, Delhi on biostatistics. Dr. Shagina has worked as a senior research fellow in the National Institute of Medical Statistics, as a statistician at the Population Council, New Delhi, and as assistant professor at R.D. Gardi Medical College, Ujjain, before she joined the National Institute for Research in Reproductive and Child Health as a scientist in 2015. Her research interest is reproductive health, clinical trials. Dr. Shagina has published more than 30 papers in reputed national and international journals. With this short introduction, I invite Dr. Shagina Begum to deliver the talk.
Good
Dr.
morning,
the floor is yours.
students. Am I audible to all?
Yes, doctor.
Yeah, thank you. Yeah, slide is visible, sir?
Yes, doctor.
Yeah, a very good morning. Today, I'm going to cover the analysis of variance and multivariate analysis. But before going to the analysis part, I would like to discuss about the scientific research. हमारा lecture चल रहा है sir. हाँ? So, the first, for any research, when we plan, it starts with the research question. So,
Doctor, the slides is not open.
not visible.
Yeah.
Okay, just a second. Now it is visible, sir.
Yes, doctor.
And the next slide, this is visible.
Yes, doctor. It is moving.
Okay. So what I was discussing, if you are planning any scientific research, so we start with the research questions. So it is important you can translate the research question into a objective. Okay, the objective should be measurable. Measurable means you can measure it and at the end you can show that, yes, this is the outcome of my study. Otherwise, you can translate your research question into hypothesis. Okay, based on the hypothesis and objective, we select the study design. And according to the study design, we calculate the sample size. The formula is vary according to the sample size. And when we select the sample number of subjects, we follow some sampling techniques. Means probability of selection should be equal to the all the participants. There are various methods. Either it will be the simple random sampling or a systematic random sampling or a stratified random sampling based on the resources your study designs. So now after that we use some questionnaire or some forms to collect the information from the subject participants. Okay, then we translate the information in a statistical form. We call it as a variable, which are we are interested to find out the results. There are different ways to collect data. Either you can do it by interview basis or by Google survey or by telephonic survey. There are various methods, but there are some limitation associated with each methods. Now, before analysis, you should have the analysis plan. How you are going to report the finding. Means you can make a dummy table kind of things that will help you to analysis accordingly. Then what are the statistical tests we are going to apply to test your hypothesis? Then accordingly we will interpret it and conclude the findings that will ultimately answer your research questions. So in this scenario, what we want to highlight is what is the role of a statistician in this whole scientific research linkage. Okay. So what is your opinion, student? When you will involve a statistician or you will take inputs from a statistician while planning your research? Anyone?
When we plan a research or something, then the data we get after performing experiments for the analysis of its mean, mode, average outcomes, there we involve in statisticians.
Okay, while doing analysis, you will involve a statistician at that time, right?
Yes, ma'am.
Okay. But in a good research, when a scientific you are doing any kind of research, it is better to involve a statistician at the beginning when you are conceptualizing the data, because he or she is going to help you to formulate your hypothesis as well as to select the appropriate study design, sample size calculation, sampling techniques, and what are the variables you are going to take, how you are going to measure it, how you are going to plan the data analysis. And while writing a proposal also, you have to specify the statistical plan and what are the tests you are going to apply when you are writing a proposal. So it will be helpful to you when you involve a statistician from the beginning. Okay. So the next is, these are the just broadly study design is categorized into 3 categories. One is observational, the another one is experimental, and the third one is translation or implementation study. In observation study, we are just going to estimate the burden of any kind of disease, or we are trying to find out the risk factors. Okay, this is just we are observing, just interviewing. We are not doing anything on the subjects. When you do some experiment on the subjects, then it becomes the experimental study. Either you are doing some strategies or intervention to see the effect of intervention, or tool you have going to check, or you have developed some device to see its effects, or drug trial or vaccine trial, etc. It will comes under the experimental study. Translation study, when you are implementing your finding in a larger scale. So this becomes based on the finding. When you are implementing it into the practice, then it's become the translation study. Any doubt in this? No?
Okay. Translation study.
Uh-huh.
It's but or with that,
ट्रांसलेशन स्टडी बता देते हैं, जैसे कि आपने फॉर एग्जांपल इन कोविड में आपने क्या देखा कि जैसे बिहेवियर चेंज है, फॉर एग्जांपल मास्क पहनना है या हैंड वॉशिंग है या डिस्टेंस मेंटेन करना है। जब इनको ये पता चला कि ये सारी जो बिहेवियर चेंज है इट इज गोइंग टू रिड्यूस द कोविड इन्फेक्शंस, तो इन्होंने मास वे में इसको इम्प्लीमेंट किया, ठीक है ना। और कौन सा तरीका अपनाया इन्होंने, इंटरवेंशन। इंटरवेंशन क्या था इसमें, अवेयरनेस जनरेट करना, ठीक है। तो अवेयरनेस कैसे इन्होंने जनरेट किया, आपके मास मीडिया दिया, आपके मोबाइल पे फोन आता था, जब भी आप कॉल करते थे तो पहले एक मैसेज आता था कि आपको ये करना है, ठीक है। तो ये सारी सब चीजें हैं जो इम्प्लीमेंटेशन में आती हैं कि हमने उस चीज को इम्प्लीमेंट किया, ठीक है, लार्ज स्केल में प्रैक्टिस में लाए, ठीक है, टू सी द इफेक्ट बाद में। जैसे आप कोई भी चीज, आप जैसे ड्रग ट्रायल है, जैसे वैक्सीन का ही था, वैक्सीन जब आई, कोवैक्सीन हो या कोविशील्ड हो, पहले एक्सपेरिमेंटल स्टडी थी, उन्होंने ट्रायल किया, ट्रायल करके बताया कि हाँ ये इफेक्टिव है टू रिड्यूस द मॉर्टेलिटी, मतलब डेथ रिड्यूस करने में ये इफेक्टिव है। फिर उसको ट्रांसलेट किया, मतलब फिर पब्लिक को उन्होंने लगाया टू सी लॉन्ग टर्म इफेक्ट इससे दिखेगा, ठीक है ना। तो दिस इज ट्रांसलेशन रिसर्च, मतलब किसी भी इंटरवेंशन अगर वो सक्सेसफुल है, जब आप उसको देखिए, जब आप एक स्टडी करते हैं तो एक छोटे स्केल पे करते हैं, मतलब मल्टी सेंट्रिक होगी या सब कुछ होगा बट छोटे से ग्रुप में होता है। फिर जब उसकी फाइंडिंग सक्सेसफुल होती है तब आप उसको लार्ज स्केल में इम्प्लीमेंट करते हैं, पॉलिसी बनाते हैं, फिर उसको इम्प्लीमेंट करेंगे, तो दैट बिकम्स योर ट्रांसलेशन और इम्प्लीमेंटेशन रिसर्च, ठीक है। तो अब आता है, अगर आपके पास स्टडी डिजाइन है, अब ये है कि एविडेंस ऑफ, देयर आर डिफरेंट काइंड्स ऑफ स्टडी डिजाइन। पहले क्या होता है, अगर आप किसी का ओपिनियन, एक्सपर्ट ओपिनियन होता है कि हाँ ऐसा करने से कुछ होगा, फिर आती है केस रिपोर्ट। तो आपको जब सिमिलर केसेस मिलने लगते हैं, व्हेन यू आर ए प्रैक्टिशनर और क्लिनिशियन, आपको मान लो एक कोविड का केस मिला, 2 कोविड का मिला, 10 कोविड के केसेस पे अगर आपने रिपोर्ट बनाई तो दैट बिकम्स अ केस रिपोर्ट। केस कंट्रोल स्टडी क्या है, इसमें केसेस भी रहेंगे और कंट्रोल भी रहेंगे टू फाइंड आउट द व्हाट आर द फैक्टर्स रिस्पॉन्सिबल और कंट्रीब्यूटिंग टू द डिसीज। तो ये हो जाती है केस कंट्रोल स्टडी। Cohort study is what, when you are following a cohort of people, those who are exposed to some risk factor and those who are not exposed to risk factors, and you are following them up till the disease occur. This becomes the cohort studies, ठीक है। RCT, you know that when you are testing some intervention or drug, then it's become the randomized control trial. After that is comes systematic review. Systematic review is what, based on the RCT or cohort or case control study, you are only doing the reviews of this kind of study to find out the outcome, ठीक है, and you do the meta analysis to generalize the finding, ठीक है। देखिए अब इसमें क्या है, अगर आप पिरामिड देखिए तो आपकी क्वालिटी ऑफ एविडेंस किसकी सबसे बेस्ट है, the best is for meta-analysis. So every study design has its own advantages and disadvantages, ठीक है। और उसका evidence भी आपकी study design, the quality of evidence is also associated with your study design. So but अगर आपको पता है कि cohort study is better than case control study, ठीक है, क्योंकि इसका evidence is, जो quality of evidence is better than case control study, but केस कंट्रोल स्टडी को कंडक्ट करना इज वेरी इजी। आपको सिर्फ केस लेना है, कंट्रोल लेना है, एंड यू विल फाइंड आउट द रिस्क फैक्टर, एंड विद इन 3 years or 5 years योर स्टडी विल बी कंप्लीटेड। बट इन कोहॉर्ट स्टडी इट विल टेक अ लॉन्गर टाइम। आपको पहले एक कोहॉर्ट बनाना है, फिर उनको फॉलो अप करना है जब तक डिसीज नहीं हो जाती, ठीक है। तो इसमें आपका टाइम ज्यादा है, पैसा ज्यादा लगेगा, मैन पावर ज्यादा लगेगा एज कंपेयर टू केस कंट्रोल स्टडी, ठीक है ना। तो डिपेंड्स अपॉन द एरिया यू सेलेक्ट and the resources you have, you can opt for the study design, but every study design has its own merits and demerits. ये क्लियर हुआ? ठीक है। Now, after doing this, all things will go to the analysis part. So in previous lecture, you know, there are two types of, if you want to analyze the data. First is descriptive statistics. You have to calculate mean, median, mode, standard deviation, percentage, proportion. Accordingly, this comes under the descriptive statistics. The another one is inferential statistics, where you are applying some statistical tests to see the association or predictive factors kind of things. Okay? If you are testing some hypothesis, then we will apply some statistical tests. There are various statistical tests to test the hypothesis. Okay? So now coming to the data analysis part. Data analysis part may first you should know. Hello. Yeah. First you should know the type of variables in your data set. There are two types of variables broadly, quantitative and qualitative. What are the quantitative variables? Anyone?
One, the variables that symbolize quantity of something.
For example?
And for example, when we do essay of drugs, then percentage purity, that is quantitative analysis.
And what are the qualitative variables?
And qualitative variables are those that we can only judge their presence or absence. The extent of that quality comes under quantitative analysis.
See, the quantitative variables are the variables you can measure with some units. Okay, for example, height, weight, BMI, cholesterol level, hemoglobin, etc. Okay, you can measure and there are some units of measurement. Fine. Qualitative variables are, they are also two types of qualitative variables. One is nominal, another is ordinal. Nominal like gender. Gender means male, female, either male, female or female, male, it doesn't matter. Okay? But ordinal, they will follow some order. For example, severity of any disease, mild, moderate, severe. Okay? So these are all education level, primary, middle, high school, higher school. They are following some order. They will come after one another. So they are ordinal variables. Okay? Now, we will go directly to the statistical statistics. Okay? There are two types of test while testing hypothesis. One is called parametric test and other is called the non-parametric test. Parametric test means the variables you are going to analyze, you should know that they should follow some kind of distribution. For example, generally they should follow the normal distribution. Okay? What is the properties of normal distribution? It's a bell shape and it will cover the 95% of observation will fall under mean plus minus 2 standard deviation. And your all the observations should be independent. Okay? Otherwise, if you don't know the distribution of your variable, then you will opt for the non-parametric test. So this is one of the example of kind of intervention study where there are two types of intervention. One group received diet supplementation and another group follow the exercise pattern. And what is the outcome variable here is to see the change in cholesterol level. Okay? And who are the participants? Participants are overweight males. And you have to see which one is effective, either diet or exercise. Clear? And how many participants in each groups? There are 50-50 overweight males in both the groups. Okay? So what is the null hypothesis? So we assume that there is no difference of intervention. That means in both the groups, the mean level of cholesterol will be same. But what is alternative hypothesis? No, the mean level will be different. Okay. Clear? This is the way we write statistically the null hypothesis and alternative hypothesis. Okay. So before going to the analysis part, while making any decision, we don't know the true value. Okay. We can assume that if you find the difference, this may be by chance. Okay. By luck or by chance, you will get the difference. But in reality, we don't know whether it is true or it is by chance. Okay. So while testing the hypothesis or making the decisions, we are committing two types of error. That is type 1 error and type 2 error. What is type 1 error? Type 1 error is this: when we are rejecting our null hypothesis, when null hypothesis is true. Okay? And the alternative hypothesis, when we are accepting null hypothesis, when null hypothesis is false. Clear हो रहा है? Hello.
Doctor?
Hello.
Your, your voice is very feeble.
Hello.
Can you bring the mic closer?
Hello.
Yes, now better.
Achha. What I was saying that while testing a hypothesis, we are committing two types of error. One is type 1 error and another is type 2 error. What is type 1 error? We are rejecting our null hypothesis when null hypothesis is true. Okay. And what is type 2 error? We are accepting null hypothesis when null hypothesis is false. Okay. So this is, and when we calculate the probability of type 1 error, we denote it by alpha and we name it as level of significance, and probability of type 2 error is denoted by beta, and 1 minus beta is what the power of your study. Okay. Hello. Power of study. So, and to highlight that here, since both the errors are inversely related. If you reduce the alpha, then beta will increase, and if you reduce the beta, the alpha will increase. And we will try to minimize both the error. Okay? How? So what we are interested in. So our aim of the study is to reject the null hypothesis. We wanted to prove that yes, the intervention has any effect. Okay? The mean of the two groups will be different. This is what is our objectives to prove. So our objective is to reject the null hypothesis, and we wanted to say that this difference is not by chance. Okay, there is true differences exist. So type 1 error, alpha, and this is 1 minus beta, this is power. So what we do, we fix this type 1 error at 5%. Before conducting the study, while planning, we fix this alpha at 5% and beta at 80%. While calculating the sample size, we fix power of your study is 80% to detect the difference. Okay? This is. And this is effect size is nothing but M1 minus M2 is what is your effect size. How much difference you are going to detect. Okay, 1%, 2%, 10%. That is what we call this effect size. This all will use in your sample size calculations. So when you follow the sample size calculation, so type 1 error and type 2 error will automatically be fixed before conducting this. This is nothing but when you see P, when you test the hypothesis P is less than 5, you reject the hypothesis. So this is what we fixed beforehand. Okay, this is what alpha is. Now it is clear. So it is always advisable to calculate the sample size for your study. Now coming back to the example, this is the same example, and we do what here. What is there? There are two independent groups and we are testing the mean. So we will select t-test, independent t-test. This is the formula, okay, to calculate the t-value. Okay, and this is the, if this is parametric, that means this follows some distributions, and we will see at 5%, this is 5%, CP alpha 0.05, and we will see what is the value at some degree of freedom. These are degree of freedom. Okay. So this is the way. See, level of significance at 5%, T calculated, we have calculated this is 10.3. What is degree of freedom? 50 plus 50 minus 2 at 98. We will go here. So if you see after 60, it has become 1.98 or between 2 to 1.98. The observation will be. So assuming it may be 1.6. So if T calculated means 10.3 is greater than T tabulated from this value, then we will reject your null hypothesis. Okay, that means we will accept our alternative hypothesis. That means there is a significant difference in mean level between the two groups. Clear? And when we apply some statistical software, it will automatically give you the exact p-value, okay, which is less than 0.05. That means there is a statistical significant difference in mean level of cholesterol between the two groups. Okay, clear how to interpret the findings? If anyone has doubt. No? Move करूं आगे. चलो. If you increase one more group, ठीक है? Exercise, diet, and there is another additional groups. Those who are doing both, exercise and diet. So this is your null hypothesis. This is the way we have to write, and this is the way we write the null alternative hypothesis. And in this case, we will not apply the t-test, okay, because there are three groups. In this case, we will apply Anova. Why? Because see, you can do in three ways. You can compare, for example, M1 M2 t-test लगा दिया, M2 M3 t-test लगा दिया, फिर M1 M3 t-test लगा के अगर आपने देखा and आपको significant value मिल रही है, that is the wrong application, because the type 1 error, when what we fix at 0.05, theoretically it will increase to 15%, 0.15 हो जाएगा. तो आपकी जो नॉन सिग्निफिकेंट वैल्यू है वो यहाँ पे आपको सिग्निफिकेंट वैल्यू मिल जाएगी गलती से. तो that is why it is advisable to do the Anova, not t-test. ठीक है, पहले आप Anova लगाइए. That means if there are more than two groups, you do the Anova. ठीक है. This is the formula. ये क्या करता है, between groups को आप within groups के variation and between groups के variation को compare करेगा. Then it will give you the p-value. So this is by statistical software. manually थोड़ा lengthy है करना. Nowadays those statistical software are freely available, you can do it, but use advisably. ठीक है, तो यहाँ से अगर आपका आया P is 0.02, that means it is less than 0.05. That means there is a significant difference in mean level among these three groups. Clear? This is the analysis of variance. Anyone has any doubt? Hello? No? आगे बढ़ो. Now, if you keep on adding the number of variables, for example, if you want to see whether gender has any effect or educational level has any effect on lowering the cholesterol level, that means we are dealing multiple variables at a time. Then we will do the multiple analysis, multivariate analysis or multiple regression analysis. Okay? This is a formula. This is your outcome variables. What is your outcome variable is cholesterol level. In this case, cholesterol level. And what is X1 intervention, X2 is gender, X3 is educational level. And if you keep on increasing the number of factors which are responsible in reducing the cholesterol level, you can add. So there are different types of regression analysis based on your outcome variables. Linear regression, logistic regression, and multinomial logistic regression. Linear regression is when we do linear regression, when your outcome variables, that means dependent variables, that means Y is in a continuous scale. Okay. Here cholesterol is a continuous scale. So we will use linear regression. Logistic regression, where your dependent variables mean Y is dichotomous, means categorized into two categories. Yes, no, disease, no disease. Fine. Then we use the logistic regression. Multinomial logistic regression, when your Y is categorized into multiple categories or more than two categories. Then we will use the multinomial regression. Now you can see that your analysis is based on the type of your variables. Okay? So it is very important to plan your analysis beforehand. Okay, how you are going to keep your variable in data set. Okay. So there is a confusion. ठीक है, आपने run किया, सब कुछ किया, कभी कभी क्या होता है, you will get the p value exactly. P is equal to 0.05 या P is equal to 0.06. ठीक है, या P is equal to 0.10 और 0.09. ठीक है, तो आप क्या करोगे? How you are going to interpret this? आप क्या interpret करोगे कि yes there is a significant difference or no significant difference? Anyone? Chat में इतने सारे मैसेज आए हैं. हेलो, एनीवन? कोई नहीं कुछ बोल रहा.
They are responding through chat box.
Okay. No significant difference. Very good. So yes, we will conclude that we don't have enough evidence to reject the null hypothesis, and because sometimes researchers try to say that yes it is significant at 10%. Okay, you will come across some paper, but it is not advisable because you have fixed your error at 5%. Now you cannot say that at 10% it is significant. Okay, so better you can say that it is not significant. So, but there are some factors which are affecting your outcomes. See, if you are not getting 5%, P is equal to 0.05, or what are the other factors which are affecting your outcomes? So we'll come across a term called bias. Bias is what? A systematic error in your study which will deviate the true findings. Either it will underestimate or overestimates the true effects. Okay? It will occur at any level while planning your study design. So when you are planning your study, try to find out what are the possible things that will affect your outcome. What are the confounding factors which are going to affect your outcomes? Okay? You will come across this, some selective bias I have mentioned here. So there is called selection bias, recall bias, loss to follow bias, non-response bias, okay? Observation bias, interviewer bias, measurement bias, classification bias. Okay? Selection bias, if you are not following the random, means if you are not giving probability of selection to each subjects, that means it is a purposive sampling. So there is a selection bias that will affect your outcome. Recall bias, if you are asking smoking habit of last 10 years, if people are, if you are asking any history-based history of any kind of disease, then it is, patient may not be able to recall exact date or duration kind of thing, then it is a recall bias. This is generally associated with case control study or cross-sectional study. Loss to follow-up bias, when you are doing any cohort study or intervention study and you are going to follow them up, sometimes the number of subjects not turned for follow-up and you don't know the end results, and then you have to remove it from the analysis. There are loss to follow. Non-response bias, though, when you contact them, they keep on responding. But there are some characteristics of the people who are generally not participate in the study. So the basic characteristics of the subject should be similar in both intervention and the control group. If there is a difference in characteristics of the participants at baseline in the pre-intervention phase, and if you see the significant difference at the end of the survey, intervention survey, then you cannot say that this is because of intervention, because pre-intervention there was a significant difference. So then you have to do some additional, you have to adjust during the analysis to show the intervention effect. Okay. Interviewer bias, if the interviewers are not trained enough to collect the information. Measurement bias, the tools you are using to collect the information, they are not validated, then there is a measurement bias. Classification bias, if you are wrongly classifying disease person to no disease group, then it is a classification bias. Analysis bias, if you are not applying appropriate statistical statistics. Reporting bias, only reporting the significant findings. Publication bias, there is publication bias, means if you get the significant results, that will get published easily then if your findings are not significant. But nowadays it doesn't matter if you have done scientific research, so they will publish. So these are the biases which can affect your outcome variables. Okay, so we'll see how to analyze data using statistical software. Okay, to stop sharing, then I will go to the screen sharing. Then this is share. Okay, it is visible now, sir? Screen is?
Yes, doctor.
Yes. So we are using SPSS software So this is exactly like Excel sheet. Here you can see that each column is variable name, okay, and each row is the subject's informations, participant informations. So the number of participant in here is 102, and there are, these are the variables. This is numeric, and these are, what to say, categorical variables. Okay. The first step to see the descriptive statistics. So we will go to the analyze descriptive, then we will go to the frequency. If we want to see statistics, see all are there: quartile, percentile, mean, median, standard deviation, minimum, maximum, then continue, and we'll press OK. ये नहीं दिख रहा होगा ना, स्क्रीन आउटपुट रिजल्ट नहीं दिख रहा होगा ना. Hello. Hello. This screen is visible?
Yes, doctor.
Now you can see here the mean, median, standard deviation, minimum, maximum of all the hormonal levels. Okay. And if you want to find out the percentage of these two are my qualitative variables, so you will see the percentage. Okay, whether disease, no, yes, this is percentage, and this is smoking, whether smoking or no smoking, these are the percentage. Fine. Now, if we want to apply the t-test, then we'll go to compare means, independent t-test. We want to see the hormonal level between the disease and no disease group. I have coded it as 1 and 0, 0 and 1, I don't know. Continue. Then if I press OK, now you can see hormone 1 in disease and no disease, number of subjects. These are the mean level, standard deviation, mean, standard error. And this is the t value. This is the degree of freedom, and this is the p value. You can see all are significant except the hormonal 3. Okay. And this is the confidence interval. So this is the way you can apply the t-test. And if you want to do the Anova, then we will go for this. My intervention group is this, and these are my continuous variable. I will press OK. Okay. Now you can see the hormone 1 is not significant among the groups. Hormone 2 and hormone 3 are significantly different among the groups, and hormone 4 is not significant among the groups. Okay. This is how we can analyze the Anova. And if you want to see which groups, so here we can see that, for example, hormone 2 is significance. Okay, we will take hormone 2 and intervention. We will go for postdoc test, bond for any correction, and we'll see which groups. We can see all the three levels. Diet increase, there is a significant difference. Diet with both the groups is significant difference. And diet, exercise is also significant. They all are the significant. The mean level between the cholesterol is significant in all three groups. You can interpret that. How you are going to interpret the finding, you have to see the mean level what is the mean level between each group. Okay, 4, 6, 7. Okay, this is lower, this is 6, and this. You can say that while following diet, the mean level is lower. So which one is better? So diet one is better. Ultimately, you can conclude that. Okay. Now after this, if you want to see the, I don't know, chi-square association, then we will go for this. Chi-square के लिए, for example, disease is lung cancer and no cancer, and smoking and no smoking. If you want to see the association, then you will select the chi-square. Chi-square is used to see the association between the two qualitative variables. So if you see, it's not significant. Okay. This is chi-square test, t-test, Anova. If you want to see the correlation means correlation between the two quantitative variables to see the linear relationship between two quantitative variables. Here we can see that this is negatively correlated, means negative sign is there. Correlation value is 0.13, means very mild. And significant means p-value is 0.17, that means no significant relationship between these two. Okay, negative means if you inversely related, hormone 1 and hormone 2 is inversely related. Okay, this is correlation. Then if you want to do the regression analysis, okay, linear regressions, so you can see dependent variables, okay, and independent variables. In my, this is the demo data. Let me check once again. These are all demo. For example, I just show you how to run it. So this is my outcome variables, and if I keep this, for example, this is my cholesterol level, independent variable. Hormone 4 is my cholesterol level, and these are some other quantitative variable. And if you want to run the effect of these three on my cholesterol levels, and this is the finding of regression. So ultimately, you can see this is the coefficient beta. If you remember correctly in my equation, y is equal to c plus beta x1 plus beta x2 plus beta x3. This is what beta. Okay, and this is whether this is significant or not. So only one hormone 1 is significantly affecting your outcome variables. Why? How much? Any change in hormone 1, unit change in hormone 1 will increase the cholesterol level by 0.279. Why increase? Because it is positive. अगर यहाँ पे नेगेटिव साइन होता like this, that means this much decrease in your outcome variable. Clear हुआ? Anyone has any doubt? नहीं? If you want to do the regression analysis, means if you want to do the logistic regression, if your outcome is dichotomous, means yes or no. Here disease is yes or no coded as 1 and 0, and I want to use these all things. ठीक है? Whether smoking, gender, or any hormonal level is affecting. So this is multiple. I will select all. I will select OK. ठीक है, तो ये सारा आपको बता रहा है. तो end result is this. This is the beta coefficient, or if you take the exponential of beta, this is become odds. ठीक है, and this is significant. Here you can see hormone 2 is significant and hormone 4 is coming significant. So, for example, odds of disease is 2.2 times higher if the hormone 4 is increased by 1 unit. Clear? This is how we run the multiple regression analysis. Any doubt, any question? This is what all I want to talk about. So from my side, it is over. If anyone want to ask any questions, they can ask.
Students, if you have any clarifications, you can ask.
See, these are the, each topics needs at least 1 or 2, 3 lectures to understand in depth concept and how to conduct the analysis. These are all just orientation kind of thing.
Yes.
Anyone can ask any questions. कुछ भी पूछ लो. Chat में, is there is any questions? Presentation में तो कुछ नहीं है ना. Presentation slide लेके क्या करोगे? No, SPSS software is not free. It is, you have to purchase it. It is license based. And hormone levels means either FSH or AMH kind of. Hormone is just variable name I have given. I have not mentioned the actual because this is, I have taken some data from studies. So it's not good to share the data. So it is a demo kind of thing. So I have not kept the original name, but it may be FSH, thyroid level, or cholesterol level. I have just renamed it as hormone 1, 2, 3, and 4. ठीक है? और क्या है? 4 new messages. Let me check. SPSS full name is Statistical Software for Social Sciences. But there are other softwares. Data is there. R is there. R is freely available, but you need to know the programming. Thoda program based. It's not a user friendly. Yes, free apps. AP Info is there. You can use AP Info. R is there. For multivariate analysis, you have to have software. For Anova, T-Test, or chi-square, there are online calculators available. You can use that one. Okay.
One question is there, either T-Test or Anova, which test gives better results in an experimental analysis?
See, t-test, when we use t-test is used when you wanted to test your mean level between the two independent groups. ठीक है? Your outcome is quantitative variables and one variable is quantitative. That means two groups में. Groups are independent and your outcome variable is quantitative. In ANOVA, if you increase one group, then you use ANOVA. Don't use t-statistics. Use ANOVA, and if you want to see which pair of groups are significantly different, then you use the post hoc test. Okay? There you can see which two pairs are significantly associated. Don't apply t-test in three groups. If there are three groups, then don't apply t-test in group 1 versus group 2, group 2 versus group 3 और group 3 versus group 4. ठीक है, ऐसे नहीं करना है. दो ग्रुप है तो आपको टी टेस्ट लगाना है. अगर दो से ज्यादा ग्रुप हैं तो आप पहले एनोवा लगाइए, उसके बाद पोस्ट डॉक टेस्ट लगा के देखिए कि कौन से दो ग्रुप सिग्निफिकेंट आ रहे हैं. क्लियर? और किसी का मिस तो नहीं हुआ है?
One question. In ANOVA, when we consider outcome as significant or non-significant?
नहीं, वो तो मैंने बता दिया. ये मैम इधर टी टेस्ट और एनोवा विच टेस्ट गिव बेटर गिव रिजल्ट्स की बात नहीं है. नॉट इन एक्सपेरिमेंटल स्टडी. एक्सपेरिमेंटल स्टडी की भी बात नहीं है. हाइपोथेसिस टेस्टिंग की बात है कि अगर दो ग्रुप हैं तो आपको टी टेस्ट लगाना है. अगर दो इंडिपेंडेंट ग्रुप है, देयर इज आल्सो वन टर्म, वो हमने पेयर डेटा के बारे में नहीं बताया है. पेयर डेटा होता है, आपने पेयर टी टेस्ट के बारे में भी सुना होगा. पेयर टी टेस्ट इज व्हाट व्हेन योर ऑब्जर्वेशन आर नॉट इंडिपेंडेंट. पेयर मतलब आपने प्री इंटरवेंशन एक वैल्यू ली है और पोस्ट इंटरवेंशन एक वैल्यू ली है. फॉर एग्जांपल, मान लो एक बीपी का ड्रग है. ठीक है, बीपी कंट्रोल करने के लिए आपने एक ड्रग दिया. तो पहले ड्रग देने के पहले आपने उसका बीपी लेवल मेजर किया, फिर ड्रग दिया, उसका कोर्स कंप्लीट किया, आइदर 2 months 3 months टू सी कि वेदर ड्रग इज हैविंग एनी इफेक्ट और नॉट, मीन लोअरिंग द बीपी लेवल. फिर आपने उसका बीपी लिया. ठीक है, तो इसमें क्या हो रहा है कि यहाँ पे ऑब्जर्वेशन आपकी इंडिपेंडेंट नहीं है, क्योंकि जो बेस लाइन की वैल्यू है उससे आपका बीपी कितना डिक्रीज हुआ. तो इन दिस केस वी विल नॉट यूज द इंडिपेंडेंट टी टेस्ट. इन दिस केस वी विल यूज द पेयर टी टेस्ट. ठीक है, तो यहाँ पे पेयर टी टेस्ट की बात आ जाती है. तो यहाँ पे बहुत जरूरी है कि आपको ये ध्यान में रखना है कि हमारी ऑब्जर्वेशन है या ग्रुप है वो इंडिपेंडेंट है कि नहीं. तो इसलिए टी टेस्ट, इंडिपेंडेंट टी टेस्ट व्हेन ग्रुप ऑफ ग्रुप्स आर इंडिपेंडेंट, एंड इफ देयर आर मोर देन 2 ग्रुप्स देन एनोवा. ठीक है, ये इन एनोवा व्हेन वी कंसीडर आउटकम एज सिग्निफिकेंट. अगर आपकी पी वैल्यू लेस देन 0.05 आई है तो देन इट इज योर मीन लेवल बिटवीन अमंग द ग्रुप्स आर सिग्निफिकेंट. ठीक है, अगर उसके बाद आपको पोस्ट डॉक लगा के देखना है कि विच पेयर ऑफ ऑब्जर्वेशन इज सिग्निफिकेंट और नॉट. ठीक है, डॉक्टर कीर्ति सक्सेना के लिए. और कोई? बस.
Doctor, suppose if we have taken a plant extract to check the efficiency, like its inhibition level, and I have 3 different concentrations and I want to test for like 5 days. Each 24 hours I am taking a data. So what kind of analysis will help me in for this?
इसमें क्या होता है ना, सी आपने एक ऑब्जर्वेशन ली एंड यू आर गोइंग टू ऑब्जर्व 5 different time points.
Yes.
Okay, and here you can see the repeated measures ANOVA. अभी मेरे पास वो डेटा नहीं है, but see there is call when you see here it is a repeated measures ANOVA.
Repeated measures.
तो इसमें क्या होता है ना, एक आप एक टाइम फैक्टर इज वन ऑफ द वेरिएबल है, वेदर टाइम इज प्लेइंग एनी रोल इन, और डोज भी एक होता है, डोज का भी एनालिसिस होता है, वेदर कितने बार आपने दिया उसका भी कुछ इम्पैक्ट है कि नहीं. तो इन दैट केस वी यूज रिपीटेड मेजर एनोवा. ठीक है?
For like enzyme analysis, if I am doing like microbial enzyme analysis, character optimization, so what kind of analysis can I do with that data?
How patients who are only one group, only one group, and number of enzymes you are studying over the time period, same enzyme or different enzyme?
Same enzyme, like I have different parameters like temperature, I have pH, I have different substrates like this.
These enzymes are independent to each other.
Yes.
Yes. And what is your hypothesis in this case?
No, I'm doing the optimization. I want to like these so much of data is there with this. So how to interpret this and which parameter is one parameter is dependent or to other parameter or not?
One parameter is, see, if you do the correlation analysis, you will come to know whether the parameters are dependent or not. If your outcome variable is continuous. Okay. Then you will see, you plot, scatter plot, you will see the pattern, how they are associated to each other, whether if one parameter increasing with other parameter or not, and whether they are significantly associated. That is what I showed you now. If you wanted to see the correlation between the, see, these are, for example, your 4 types of enzymes. Okay. Okay. And if you run the correlations, so you will see here. See, hormone 1 and hormone 2 are negatively correlated. Fine.
Okay.
Hormone 1 and hormone 3 is positively correlated. Hormone 1 and hormone 4 means if your enzyme, for example, is here also it is positively correlated, but if you see, this is the significantly correlated. See, and correlation values varies from -1 to +1. 0 means no correlation. Minus means negatively correlated. Positive means positively correlated. If you increase the level of hormone 1, the other hormone 1 value will also increase. ठीक है ना? तो ये आपको ऐसे एक straight line में दिखेगा. And it is significantly correlated. This is the way. तो ये आपको correlation value and this is moderately correlated. ठीक है? ऐसा. अगर आपका यही value अगर आपकी 0.84 आती तो आपका strongly correlated. है ना? ऐसे होता है interpretation. Yeah.
Thank you. Thank you.
Thank you. Thank you very much.
Any other questions?
I think there is no question in the chat box.
Thank you, Dr. Saina, for joining us today.
Yeah. Thank you very much for inviting. All the best. Bye. So I'm leaving. Thank you.
Thank you. Students, we will move on to the third presentation of the day. We have with us Dr. Premlata, scientist from SISTI. She will be explaining you about the SISTI's research facilities and the products that have been developed by SISTI laboratories. I invite Dr. Premlata to deliver the But
Good afternoon, all. So, am I audible now? Anyone can reply. Am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. Today I'm going to present about our Srishti's lab facilities and activities. And during your around 3 to 4 day session, probably you have got almost a brief idea about our Srishti, and Professor Gupta had interacted with you. What is our purpose for this workshop? And so I'm not going to in details. So I will, in brief, I will tell you. So what is the lab facilities we are having, and once you are coming here, or you can, you can do here. That's the thing I'm sharing. So this is the Srishti lab, means our lab's full name is Sadbhav Srishti Sanshadhan Natural Product Laboratory. So everybody knows that where you are coming, they are simply telling it is Srishti lab, but the full name is Sadbhav Srishti. Why so? Because one of the trusts from Mumbai, that is Sadbhav Trust. So about 22 years ago, that trust has supported us to make this natural product laboratory. That's why it is called as Sadbhav Srishti Sanshadhan Laboratory. So as you know that our honeybee network, it has different networks such as GAN, Srishti, and also that NIF is also one of the branch. So this is the year when the first honeybee network started in 1989. And after that, this is the Srishti established in 1993. And in 1997, the GYAN established. And later in 2000, this Sadbhav Srishti Samshodhan Natural Product Laboratory established. So this is our lab. This is the whole overview of our lab. You can see. And what is our lab's objective? That is, our lab is conducting Shodh Yatras, where our lab people are going with different incubators to different parts of the country to collect different samples and document some practices of farmers. And that practices we are taking to our, bringing to our laboratory, and we validate the practices, and we try to make products from that and make the formulation, and then we produce it as a product. That product might be an agricultural product, that might be a veterinary, or it may be used in human application. Then the next is our validation and value addition of the grassroots innovation and traditional practices. Because as you know that our process is little reverse, because everyone is doing that, they are doing some experiment in lab, and they are, the next step is taking into the field or any other application outside. But we are collecting the information from outside, then we are practicing here in the laboratory. This is just a reverse process. Then we are producing some eco-friendly non-chemical pest management for agriculture or animal healing. So whatever may be the application, our priority is to make it non-chemical. And next is generation and sharing of wealth with grassroots innovation. We share the financial benefits occurring from the commercialization of new product and technologies, and we share this. That is the tech transformation system is also going on here, and we create the products some for non-commercial as well commercial diffusion, and we do some organization of. We are the organization of entrepreneurs. We encourage to the young generation to be entrepreneurs for this. As we are conducting the BIIS, we have some other, we are also the partner of BIIS to promote some young generation to do startups. That's why we are also inspiring to be innovative of our lab and do your startups and start here as well. And the main purpose objective is the scientific discipline to bridge the gap of informal and formal knowledge. And these things Professor has explained very well. What is the bridge the gap of informal and formal? Because we are here the scientific people or the scientific lab working on the formal knowledges, and we are collecting the informal, that is the traditional things. That is the thing combination is called as the informal and formal bridge. So these are the fields we are working in our laboratory. These are the major research focuses, just like phytochemical screening. So we are collecting, we have a good medicinal plant database, and also we are collecting some other, waste things, waste materials, just like weeds, and we are doing the phytochemical screening for different applications. And we have a good natural microbial data bank. So yes, we have that is called the Cystis microbial data bank, and we are also working on that microbes to produce some metabolites which can be used in agriculture, veterinary, as well as in human application. We are also working on veterinary things, veterinary formulations, where we are working on the cattle and other domestic animal diseases, and we are making product on that. We have good facilities of anti-microbial screening, and also we are working on some paper-based devices, and also we are working some molecular biology and cell line development work. And currently now all are focusing on that in silico drug designing. We are also working on that. We are getting clues from that. Then we are also implementing these clues in our wet lab. So this is a brief overview of our laboratory. This is the wet lab. You can see here is the lab staff's room, and this is the wet lab. And we have a good analytical lab. We have one phytochemistry lab, and we have also molecular and cell biology lab. And here is we have three biosafety cabinets. One we are specifically using for bacteria, two, and one we are particularly using for fungus. As you know, fungus are generating more spores, so we are not taking risk of contamination. So that's why we are using that chamber only for fungus. And here is this one is the view of our. We have a good cold room where we have a lot of microbial cultures and also some extracts we collected on Shodhyatra sample. So this is the storage, and here is the instruments we are having with us. The first one you can see the atomic absorption spectroscopy, and probably you know I'm not going to say the use of these things because you can very well know what is its application and you can Google it as well. But we are having these facilities. Once someone is coming to our lab, so they can avail these facilities. And we also have that HPTLC, and this is the HPLC. We have a good HPLC, and GCMS facilities are also available. And this is we have two centrifuges, one big and one medium one. And we have a fermenter for large scale microbial culture. And this is the gel dock system is available after the band reading we are doing. And this is a ELISA plate reader. And these are the incubators we are having to for our storing our cultures for growing. And this is the orbital shaker. It is also having the thermal capacity to maintain the temperature for the culture. And we have two lyophilizer. One is this one and another one is this one. So everything is ready for a good natural product laboratory. So here is the microorganism details we are having. You can see we have in our Shodhyatra, we have visited almost all states of the country, and you can see this is some states are very cold states, and also some are in a very hot summer. We visited some states which is having very extreme temperature, so we collected sample from that region. And here is the figure we have with us. That is the bacteria. We have around 4,054 cultures. For fungus, we have around 1,923. And actinomycetes, 2,613. So all total, we have around 8,790 cultures. But the thing is that we are conducting such type of program so that you people can utilize these microbes as a resource. And we may develop some of the generate some compounds, and we can apply this as a source in different fields. So these are some experiments, lab experiments we are conducting. Such the first one is we are doing the anti-microbial screening. So this is the first one. We are doing some primary screening. After primary screening, when we are getting some novel hits, then we are going for secondary screening and studying the zone of inhibition. And after getting some good results, we can proceed with the characterization and further experiments on that. And this is one phosphate solubilizing activity. So why we are performing this? This can be after getting the activities, we can proceed for developing a growth promoter. So this is the PSB things we are doing, and this is cellulose degrading activity. And we have found many of our microbial cultures, those are showing these activities. And we are also doing some secondary and tertiary screening on that. We are also doing, after the third step, we are also doing that pot experiment. But later our purpose is to take this product to field. And this is some pigment producing microbes. So these you can see the how good pigments are showing our bacteria and our cultures. So you know the application of pigment. So it can used in used as a food grade. It can used as a cosmetics. And for this we are always choosing some good colors. But thing is that if it is a chemical or synthetic, so there is a lot of hazardous issues, carcinogenic issues. But when we are getting such colors and such pigments from a natural origin, so we'll be blessed that we are having these things. And thing is that we are getting it from the microbes, so that you are not going to lose the biodiversity. So that at any time you can culture and subculture and you can get your pigment. Okay. And this is some, some weed extracts we are using for the germination of the crops. So we applied in the maize and tomato seeds germination. So that experiment is also in the pot stage. So we are also going to make some products on that extract. And we are also working on some entomopathogenic fungi, and we also attempted that day, you remember Professor told you that we know that nutrient agar and PDA, that is the most commonly used media for culture of the bacteria and fungus. But still we are attempting, is there any other option to make some low cost media? So we are using some pulses like black gram, finger millets, and simply we are isolating the microbes from soil. So we took the soil as a soil media. So we prepare the soil extract agar media, and we just got these cultures from this media. And we are also proceeding with some other screening activities with this. And this is, as I told, we are also working on some paper-based device. This is one blood grouping things that, as you know, for a blood test, we are going to the patholab and we're doing, but now we are trying that you can do it yourself in your home. So in this device, it is a very portable device, and you can use, and its accuracy is also very perfect. So this is the thing about our lab facilities. So later I am going to show you some of our lab products, and then I will open this session for your queries. So let me show you the lab products where we have developed and we are under process. My screen is visible.
Yes, ma'am.
Oh, no, just 1 minute. Here it is. I think now it is visible because that is the previous one you saw. Is it okay? Okay. So
Yes, ma'am.
yeah, I'm not going to the first slides regarding our objective. I already told you in my previous presentation. So I'm simply going to the products. So we have these herbal agro products. You can see we have, this is the particularly from the Srishti products. Okay. We have these biopesticides. It is already available in the market. We have these growth promoters. Okay. So it's already commercially available, and we are also in the process of making some other things. So a lot of interns are also coming, and we have assigned them to do some works on that, and it is already in the process. And if you people are coming also, you will involve in making this type of product. Okay, these are all. This is the products are the Srishti Sudarshan. So it is a liquid formulation. You can see. So we will share you this PPT with you. So I'm not going to tell everything in detail. So this it is from this title itself you can know that what is agro products, and this is, and we can say this is Srishti's products. That is our pride, and this is the details that what is the product name and what is its application. Just like Srishti Shakti, it's a growth promoter. Srishti Prayas, its growth promoter also reduces the flower seeding, and these are the applications and products you can see from this slide. I'm not going in detail. And this is some veterinary product. We have one, you can see that Srishti Galactogoth and Masti Remedy. You know, cattle are facing mostly the mastitis problem. Recently we developed this product. This product is developed by one of our veterinary scientists, Dr. Jaideep Kumar Parmar. So this is the currently launched product, and also he produced one distro worm. It is used for the killing of that insects in veterinary problems, and these are the all Srishti's veterinary products, and this is the application. So it can be used as a herbal appetizer for livestock animals. It can be used as to control intestinal worms and treatment of bloat, and so enhancer, milk enhancer. So everybody, if anyone is doing that, cattle as a, their income source, and definitely they would like to know the milk enhancing things, and it should be a natural. Everything is that we are very less in chemical things, and these all are natural things. And these are the human products. We developed some zymatic ointment for eczema and psoriasis, and we also developed some pain relief and some cosmetical things, skin glow cream, and care, and some mosquito repellent cream also we developed. And still we are also working on some other products on human applications. And yeah, you can see these are the product and their applications for human. So all three things, the agriculture, veterinary, and human application is every time in our concern. So we continuously working on that every year we can make some products. And this is the program we are expecting that whether you are an awardee or a participant, you can come here, and you may try something that so that your contribution may reflect as one of the product of Srishti. And this is the Srishti Parak, as I told you in my previous slide. That is the paper-based things for blood grouping. And this is another paper-based device that is used for just see that mastitis is, the cattle is having the mastitis and treatment is going on. It is a PS-based study, but you are doing the treatment, but how you know that how much it is effective? You can take the milk from that cow and you check here, and the color will show what is the stage of that mastitis. If your treatment is working, it will show you here that yes, it is working, and now it is reducing to this stage. So each stage you can perform this test, and you can get a good result, and you can convince whether your animal is responding or not. And this is one of our scientists, Dr. P. Vivekanandan. He has started on the biocontrol fungus against plant pathogens. That is, he worked on this Trichoderma hyoscyarum and developed one product on that. I'm just going to show you this product. Yeah, this is in a powder form, and currently we have not sold it. We just sent freely to the farmers to use it, and we collected their feedback, and we got a large number of good feedback that it is really working good. So the next step is we are going to commercialize. We are in the process of talking to the that Amazon and the other commercial persons, so that it could be available shortly. And these are the team, our farmers incubators, and these are the local farmers. And because our scientists not only working inside the laboratory, they are working very hard. They are directly going to the field and apply their product and see that how much effective it is and getting the responses, and also asking the farmers that what problems they are facing, so that they can gather that problems, and they can come and we are sitting here, and that is the problem affecting this area and what we can do for them. Then we are starting what natural resources we can use. We are developing protocols and we are working on that. You can see that this is not only limited to lab or not only limited to farmers. It is a combined work. And next is, this is the extraction of chitin from shrimp waste. Actually, this is the thing the previous BIIS students like you, we have already, this is BIIS-11, we have almost already completed 10 BIIS programs. So up to BIIS 1 to 4, we conducted offline mode. And as you know, after pandemic situation, nobody allowed for a physical program. So we conducted it online. And now you people are judged during their assignment, quiz and other things. But that time they were coming to laboratory. Now we are thinking now situation is normal and you can come and again resume the work. So these are some BIIS students work. They have chitin from the shrimp waste. And they have did some experiment. This is the participant Anita. She has done this. And this is isolation of microbe from 9 samples of marine waste. Okay. So like Sodatra, we are collecting some soil samples and we are isolating. So here it's from the waste also we are collecting some microbes, because we don't know that in a waste, that means in a hushed situation, if a microbe exists means it has some nobility in that. So that was the purpose to isolate the microbes from these areas, and the media preparation they have done, and they have prepared later on this waste using this media. Okay. And this is the result generated by her. And another one is a project from some Suchita Le. She has done a project on evaluation of grassroots practice for crop protection. So it is not like that we will develop one proposal just like the scientific people are doing. We are taking the farmers' practices in our Honeybee published database, and we are working on that. The students came and they took the practices and they started validating that for crop protection, and these are the results for that. So another BIIS student, that Vijay Vardhan Pandey, he has done the evaluation of pesticidal efficacy of one of the plant extract against sucking and chewing pest. Okay, so this is the result generated. So this is some glimpses that you people also can do like this, and also you can do better than this. So these are some patents from our work. We filed around 12 patents. And as you know, the patents are filed in the name of the innovator, because they are the main person who who has given this idea. So 3 patents has been granted and 9 under process, and it is also going to approve. And we have got these awards and recognition from different parts. And total, we have developed 66 products at Srishti Lab, and currently 7 under development. And as the lab product belongs to some pesticides, agricultural and veterinary things, this is also our lab products. Publications is one of the product, I would say. Because see, these are the very good journals of Taylor Francis, BBRC, very reputed journals. So our work has been published and recognized in such journals. And we are also expecting many more like that from you guys. And we have some short communications, we have some reports like this. Okay. And thank you. So if you have any queries regarding our lab facilities and what you can grab from us, so you can freely ask. Okay. Question and answer. So I was already. So you can ask any question, or I can see your chat box.
Students, if you have any questions or clarifications or doubts, you can ask us. Students, is there any update regarding the practical exposure to labs?
Chat question.
We are working on it with the BIIRAC. We are having discussions with BIIRAC. Professor will, once we get answers from them, professor will update you. Okay. Any other questions? Okay. So in case there are no other questions, then we will wind up this session. Thank you all for joining us today. Thank you so much.